Is that okay?
Yes.
Okay, great. Okay, so we're gonna start session. Welcome to the first BrainHack School project pitch, and we are starting here in Taiwan. I know Isil is on. I see Isil is online. So hi Isil.
Yeah,
Hi.
hello.
Yeah,
Hi.
yeah.
Excited.
So yeah, thanks for helping to organize everything and for this opportunity. And
Thank you all. Thank you.
yeah, so we're gonna also now move on to the project pitches. Just so to orientate everyone, we have about how many people? Let's see. Was it 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 people to go through this morning. So it'll be a bit rushed, but we are not. I know we put about 5 minutes per person, but you know we just want to keep things moving. So if you go overboard and we're gonna take a little bit longer, really it's okay. Okay. So without any further ado, we're gonna start with. Sorry.
First, we can also have discussions.
Oh yeah.
Which will explain to them later.
Yeah. Correct. So Charlene's here. So we encourage people, if you have questions, you can post them on the hub, on the Discord hub already. You can interact there because we may not have time to have everyone kind of talk live in this session, right? So you can leave your questions there or you can pick things up from there. And since this is recorded as well, we welcome everyone, international community. When it comes to your time zone and you view this, you can pick up questions in the Discord channel as well. We should also say that the project pitches here are for I would say all of them here right now are Taiwan students, but we generally also welcome people, international students who are interested to reach out if they are interested or had questions about the project.
There will also be a channel called Project Channel, which will be made public shortly under the BrainHack School channel.
Yeah.
So all the projects will need to put like a slide or something, and then people can start discussing there.
Yeah.
So all the discussions to be under the same thread.
Yeah. We'll put up the details for that one also later. That will be the project 2023. There's an example there. Isil already put it up this morning. So we'll talk more about that afterwards. So that should be it, right? Okay. Kevin, Jun-Qian, anything on your end?
No, I think we can just proceed to let students to introduce their projects, right?
Okay, so I'm going to share the slide. Let's see. Let me share. My screen is sharing now, and I'm going to share. Can y'all see the shared screen?
Yep.
Okay, good. So Amanda, go ahead.
All right, so can everyone hear me? All right, assuming that they can.
Yeah, okay.
Okay. All right, so since, background information is mandatory, a little bit of a self-introduction. So my name is Amanda Lin, and I'm one of the TAs for this Taiwan hub, but I also do have like a project too. Oh, that's stressing me out.
Okay, all right. Sorry, no.
I also do have like a project to, share with you guys. And I'm currently in Dr. Charlene Lee's lab, pursuing a master's degree in linguistics. And I also received my bachelor's in theoretical mathematics. All right, so, I was kind of struggling to find a title for this presentation because I feel like it's an assortment of different things. So I think this is kind of like the best title that I could come up with. And this project, I've been working on it for a while. And initially, I only wanted to include the EEG analysis. But kind of like along the way, I came up with like different programs, which I think are really crucial to this project as a psycholinguistic experiment. All right, so, a psycholinguistic experiment. So like the first step to conducting an experiment is to have experimental stimuli. And Dr. Lee always says that, the stimuli are the soul of the experiment. So it's really important. And, you know, I think psycholinguistic stimuli are incredibly difficult to construct, and we've been putting a lot of effort into constructing the stimuli. And why are they so difficult? It's mainly because, you know, these stimuli, in our case, are sentences, and certain features of these sentences have to be matched, and there are certain criteria that have to be met as well. And, you know, in order to achieve this, we will recruit a bunch of participants to have them rate these stimuli features. And how this is done is that, you know, we will send, we will ask participants questions such as, you know, how plausible do you think this sentence is, or how emotional do you think this word is? And so we will send them Excel sheets that contain these questions, and then the participants will send us their responses back in the form of Excel sheets. And this means that, you know, our lab's Gmail account will be constantly overwhelmed by a bunch of emails, which highlights the importance of, how do I get to the next slide on a Mac?
Sorry. Oops.
Is it like,
is that right?
Right, yeah, right
Okay.
click.
I think tap.
Oh, okay. So, in case you didn't know, like, there's this fancy thing called Google Apps Script, which is actually JavaScript, and there's a bunch of, you know, cool things that you can do with Google Apps. And what this script does is that, you know, it automatically replies to incoming emails, and then automatically labels these emails, and then automatically uploads attachments to designated Google Drive folders. So this is kind of like an automated program to kind of facilitate the entire data collection process. So yeah, that's the first step, data collection. And then the second step is we need an automated program to help us organize the rating results as well, which are just, you know, Excel sheets. And so I wrote a program in Python that does this, and here's a screenshot of the code. And it's nothing too fancy. It's basically just like a quick implementation of a library called pandas in Python. And I'm glad that, you know, it's been slightly helpful, not powerfully helpful, but it's helped us a bit. All right, so getting to the main course, which is the EEG data analysis itself. And I should first say that it's a reanalysis of like a data set in our own lab that was collected like several years ago. And as for why this reanalysis is needed, I'll return to that later. So the methodology. So since it's a reanalysis, certain aspects of this reanalysis have to be kept identical to the original analysis. And in this case, these are the pre-processing steps. And so I ended up doing re-referencing and filtering in Matlab, which is like the default programming software that we usually use in our lab to analyze EEG data. And aside from these two steps, everything else was done in Python, and including the stats as well. And so the question is, why is this reanalysis needed? I feel that, you know, this reanalysis actually provides us with like a different perspective. So, you know, what distinguishes between ERPs and EEGs is that ERPs are, roughly speaking, averaged EEG signals because EEG signals contain a lot of noise, and such noise can be assumed to be randomly distributed, which means that if you take a lot of trials and put them together and average them, supposedly noise should be canceled out. And so averaging is kind of like the most traditional approach to ERPs. Whereas in this reanalysis, we adopt like a regression-based method, which to my understanding, I think is kind of like another way of removing noise by assuming that experimental effects are linearly related to experimental manipulations, which in some cases might not be too accurate of an assumption, but that's just like one of the possible ways that you can approach ERPs. And so, yeah, and I think this program that I wrote kind of has brought us some new insights, and I think the results are really exciting. These are not the results. These are actually some other stuff from some thing that I did a while ago. But yeah, so I think the results, I'll leave them to the final project presentation. So yeah, that's about it.
So you're trying to apply the RERPE, the regression analysis onto the EEG data, right?
Yeah.
Okay. Using Python, right? Okay. That's a very good project. Okay, thank you. Any questions?
Questions?
Or anyone from Discord has questions?
Let me check.
Not
No,
yet.
it's okay.
I guess people are trying to catch up because I think today we will be moving.
Yeah.
So it's okay. I think people can have some time to digest, and then later on we can move the discussions to the main.
To the main
Big
hub.
hug. All right.
Yeah. Okay, thanks, Amanda.
Okay,
So,
guys.
good job. And we did good on timing. So we'll move on to the next person. Who's the next person? Yeah, can you help keep the time? So the next person is Yu Xuan. Is that right? I'm going to stop sharing. Yu Xuan. Is it Yu Xuan? Yu Xuan, Yu Xuan. Where is Yu Xuan? Not there? Oh, it was going to be in person. Yu Xuan. We can always move on to the next person first until she comes. Okay. Or you can check with her. Tsu-Chun. Is it? Okay.
Yeah, he's there.
Where?
Yeah. So.
Oh, this one? Okay. Tsu-Chun, we can't hear you. Are you speaking? I can make you representer. Is it?
How's my lecture?
Yeah, can you share your slide?
Okay.
Oh, you can share it with WebEx, or do you want me to share it for you?
I will show it by myself. Thanks for helping.
Yeah, please share it with the WebEx. I think that'll be easier.
Okay.
Okay, good.
So Tsu-Chun, please try to keep it under 4 minutes.
As best you can. Keep it under 4 or 5 minutes. Yeah.
Okay, I will try my best.
Yeah.
So, hello everyone. My name is Tsu-Chun Yang, and I'm from NTUCN. Today I'm going to introduce my project. My project name is Predicting Emotional Responses to Competitive Outcomes using Resting State MRI Functional Connectivity Analysis. And
Wait.
Can everyone see my slide? Or okay.
Yeah, we missed out your intro. Can you intro yourself again? Sorry.
Oh, okay. Sorry about hello everyone. My name is Tsu-Chun Yang, and I'm from NTUCN. Today, so should I repeat my title again, or?
No, it's okay. We read your title. You can go ahead.
Okay, thanks. So my aim is using resting state MRI to create functional connectivity metrics and generate machine learning models to predict subjects' emotional responses upon receiving different outcomes. And here is my data. The data is from 36 participants was provided by my senior Meng Lin and will continuing be added recently. In this data, we will see the emotional responses of the subjects after facing the following 12 combination of outcomes. For example, we will see maybe a participant maybe will win the game, but he or she will receive the punishment, maybe strong, medium, or weak by him or herself. This is one of the combination. And it should be noticed that these 3 types of outcomes, that is orange, yellow, and blue, are independent. So This is my I want to do in my project, and next is my method. First, I will do fMRI. I will use fMRI prep or CCAP to pre-processing my data. The point is that resting state MRI is more susceptible to unrelated signal than task-based MRI. So filtering and chance removal may necessary to reduce the signals. And next is after that, I will do the functional connectivity metrics for the feature of machine learning. Here I have shown 3 methods, but I'm still not sure which one to use. It may depend on the number and locations of brain regions activated in the resting state. And the last part is about machine learning. Here I will focus on the modeling part. Since my sample size is small for n equals to 36, but I have a large number of groups, I will choose to use a simple model such as SVN or random forest and try to optimize it. And this is the end of my project. Thanks for listening.
Okay, thanks, Tsu-Chun. Any questions from anyone? You kept it very good timing. So, any questions from anyone? Okay, if not, we can move on to the next person, Chun-Yi. Chun-Yi,
Yeah.
can you share your screen in the
Yeah,
WebEx?
sure.
Thanks.
Can you see the PowerPoint?
It's starting up.
Yeah.
Yep. Okay, go ahead.
Okay,
Yep.
sure. Hello everyone. I'm Cheng-Yi from NTU as a PhD student, and my project is the neural mechanism of nature-based intervention with nature environmental information of forest. First of all, I would like to introduce the background of nature and mental health. The effect of exposure to nature on cognitive function and mental health aspect was studied by a variety of experiments. The nature exposure will increase the cognitive function, especially attention ability, and also reduce the stress, and therefore can enhance the mental health. The effects are affected by the natural feature, including size, type, and quality of natural environment. Also, the time and experiment spent on natural environment also affect. Although nature are generally good for cognitive function and mental health, but nature will also induce a negative effect to some people due to negative experiments. Also, the preference to nature or urban environment, so-called environmental preference, is also important for the benefit from the natural intervention. One study showed people with nature preference can improve more attention ability and positive mood. However, people with urban preference increase the attention ability, but decrease the positive mood after the natural intervention. So the aim is to investigate the neural process of the natural environment and urban environment information in different individuals. And I have 3 specific aims. First is to evaluate the environmental information be processing in brain with the natural stimuli paradigm. Second is to identify the role of the ventral medial prefrontal cortex in environmental preference with inter-subject correlation method. Third is to explore whether the deformal network can modulate the effect of nature-based intervention with a functional alignment method. And the data set I would like to use is collected in the NCCU Image Center. The experiment will ask participants to watch 2 sets of 10 minutes video with 5 scenes for both natural and urban environment. And I will adopt the natural stimuli paradigm to analyze the relationship between stimuli feature and neural processing. For this study, we expect the information of natural environment are more harmony, which would induce least local prediction error. Although the natural processing rate for both video are similar in the visual cortex, The neural processing pattern will be different for nature and for urban people. The pattern difference can be captured by the intersubject correlation. And I expect the natural video will induce this noise information in the VMPFC and therefore show faster alignment rate in deformal network. The faster alignment rate in deformal network will reload the cognitive resource, therefore can increase the attention ability and reduce the stress. The keyword for this study is the nature-based intervention, environmental preference, and the naturalistic paradigm. And thank you for your attention.
Okay, thanks, Chun-Yi. Very good. I think we can move on to the next one. I don't see any questions or people. And the next person is Meng Hua. Meng Hua, right? Is it Meng Hua? Are you there?
Hi. Can you hear me?
Hi. Yes, yes.
Okay,
Can you
so
share your screen?
yeah, of course.
Yes. Okay, great. Then whenever you're ready, you can start.
Okay. So good morning, everyone. My name is Meng Hua Guo, and my advisor is Albert Yan. And I will start it from the background. So according to the research, there are about 70% of schizophrenia patients suffer from hallucinations or delusions. Some studies have demonstrated that the abnormalities in the triple networks, including deformal network, central executive network, and salience network, is the reason that contributes to delusion and hallucination. For example, there are higher threshold values in the right anterior cingulate cortex, which is belong to salience network, and left medial superior frontal gyrus, which is belong to deformal network, was higher in the schizophrenia, and the latter is negatively correlated with the severity of delusion. Another paper published that year also found that functional connectivity between dorsal PCC and dorsal precuneus decreases during delusion, and both of these regions are parts of the deformal network. Many theories have been raised to try to explain hallucinations. In recent years, a quadripartite model becomes popular, since it combines several findings regarding the triple networks and hippocampus. In this model, it is believed that it is the unstable triple networks that create the possibility of memory-based sensory input from the hippocampus to salience network under appropriate environments. In the meantime, the deformal network activity would decrease, so the hallucinations occur. It's until the central executive retakes the control, the symptom will end. So why is this issue so important is because that delusion and hallucination are often social stigmas for schizophrenia. And also the repeatedly relapses of this symptom might cause irreversible brain damage. So from clinical aspect, early diagnosis and symptom prediction might prevent this kind of brain damage. And from the research field, this study might indirectly shed light on the network dynamics and structural connectivity. So the first aim that I'm trying to do is to discriminate the schizophrenia patient from healthy control, and also try to discriminate whether one had experienced delusion or hallucination. And the second goal is to clarify the underlying mechanisms of these two symptoms in schizophrenia. The dataset I will use is from Taipei Veteran General Hospital. There are 341 healthy control subjects and 213 schizophrenia patients. And the criteria is the absence of other psychiatry and neurological disease or substance use disorder. The method I will use including in simple empirical mode decomposition. It is a noise-assistant version of EMD. It could separate the intrinsic oscillators of all signal into different scales, and it is called intrinsic mode functions. I will extract some features from those IMFS and feed them into some machine learning classifiers. And then branches causality and functional connectivity will be implemented to have a better understanding of the underlying mechanisms. So this is my presentation. Thank you.
Oh, okay. Thank you, Menghua. That's very good. Can you also upload your slide later to the Discord? Okay.
Oh, okay.
Yeah. Thank you so much. And we'll go on to the next person. Switch over to Yusuke. Yusuke is the next one. Are you there,
Okay,
Yusuke?
yes, can you hear me?
Yes, yes. Okay. Can you share
Okay,
your
great.
screen?
Yes, okay.
Menghua needs to stop sharing the screen. I can change to make presenter. Okay, Yusuke, you can share your. Okay, great, got you.
Can you see my slide?
Yes, you can start whenever you're ready.
Okay. Okay, so my name is Yusuke, and I'm from Graduate Institute of Linguistics. Okay. Oh. Okay. Actually, I've been fascinated by fMRI studies of language, but I have no experience in it or statistics on coding, so let alone Python. So I was a little bit worried about if I could survive this course. Yeah, but so far so good. Okay. So the project title will be an fMRI analysis of different types of words. Because I'm from the linguistics department, I'm a language enthusiast. So I want to combine these two topics. And my motivation is to explore whether neural activation patterns differ across categories of words. So, for example, a brain activation pattern when participants are listening to nouns or verbs or static or dynamic verbs. Okay, and the dataset I'm going to use is an open neural dataset, and this dataset contains pre-processed fMRI data recorded during a listening task where participants listen to around 700 words. And these words differ in syntactic and semantic category. And about the method, actually, I haven't decided yet, but since I have no idea which part of the brain will be activated, so I think I'm gonna use voxel-wise whole brain analysis, but I think I'm gonna discuss with my TA. Okay, so this is my tentative project design. Okay, and that's it. Thank you.
Okay, Yusuke. Thanks. It's a very bold, but it should be very interesting. Okay, so I think we saw a question also about the schizophrenia data set. I think maybe we should ask people to post on the Discord if they have questions. Oh, they are. Okay, good. Yeah, because in case the WebEx, like once we finish this session, it may not be logged on, right? Yeah, we will use. Yeah, I will talk about the template maybe after the whole session. So the next person is who's the next person? Hsin-Yu. Are you all there?
Yes.
Okay, great. Can you share your screen? See Chia-Yu's screen. Okay, good. And so whenever you guys are ready, please start. Are you all speaking?
Yeah.
Okay, all right. Please start when you can. Yeah.
Okay. Hi, everyone. I'm Hsin-Yu, and my teammate is Chia-Yu. We are master's students majoring in psychology. Both of us are learning brain imaging analysis in fMRI studies. And in our BrainHack School project, we would like to inspect the resting state functional connectivity in patients with fibromyalgia syndrome. Fibromyalgia is a chronic disorder that causes pain and tenderness throughout the body. The pain would be in more than 3 locations in the body for more than 3 months and accompanied by specific tender points. The syndromes of patients include widespread musculoskeletal pain, stiffness, soft tissue tenderness, general fatigue, and trouble sleeping. The disease affects 2 to 4% of the population, and more than 80% are women. Through this project, we want to explore more skills and knowledge about neural connectivity in FM patients. And our aim of the study is to fully understand the mechanisms involved in FM pathology. To be more specific, we want to know the difference in endogenous pain modulation between FM patients and healthy control. We use a data set from OpenNeuron. The title is a behavioral, clinical, and brain imaging data set with focus on emotion regulation of females with fibromyalgia. Although this data set focuses on emotion regulation, we will utilize it between groups, resting state brain images. By referencing Janet's study in 2012, the dysfunction of the descending pain modulatory network plays an important role in the maintenance of FM pain. This will focus mainly on 2 brain regions in the pain inhibitory network, the RACC, that is the rostral anterior cingulate cortex, and the thalamus. And we will do the C to voxel correlation and ROI to ROI analysis and compare the functional connectivity between the 2 groups. We expected to see a similar results that FM patients have difficulty descending pain inhibitory information. And if time limits, we want to do another analysis like graph theory and to see whether these differences, different ways of analysis lead to the same results. That's all of our presentation.
Okay, thank you. Very good. So again, please post your slides onto the Discord channel. I'll talk more about also the posting for the projects channel later.
Okay.
Thank you so much. This is great. And we'll have the next person is Jin-Xiang. Is that right? Is it Qin-Xiang? Qin-Xiang.
Hello, everyone. Can you hear me?
Yes. Okay.
Okay, thank you.
Are you able to share your screen?
Yes.
Okay. Okay, we see your screen now.
Okay.
All right, so when you're ready, lie detection. When you're ready, please go ahead. Yeah.
Okay, hello, everyone. I'm Chin-Shiang Ma. Okay, my background is electrical engineering. And I have a full-time job in Acer. So sorry, I have very limited time for this project. And I got an instruction that I can only have 2 pages for a pitch presentation. So it's a very simple draft and a preliminary idea of my project. Okay, next page. This idea is from the 2 drama. One is Lie to Me. It's a long time ago, American drama. And the people, Paul Ekman, he has studied a line a lot in the past, and he said we can distinguish the people who is lying by his micro expression. So my project is want to build a lie detector, use the EEG and maybe fMRI with micro expression or eye tracking. Use eye tracking is because someone said that when you lie, you may look at the left side or right side. You just don't look direct to the people you talk. So maybe eye tracking can tell us something. So my special eyes want to solve the integrity issue in academic. We have some integrity issue recently in academic, and also the partition. Because you know the hard drama recently, the wave maker, you can see the partition always lies to the public. So if we can have this lie detector, maybe we can tell who is worth to trust. Data set is still looking for, but sorry, I just can't always present last night, so still not well prepared for the data set we can use. And I just found some paper they used before to choose identification, but they use the EEG only. So maybe we add a micro expression or maybe fMRI or eye tracking, we can do better than they done before. So my method want to be used is I want to use the deep learning method to learn the pattern of line when we got the EEG or the micro expression or eye tracking data. So after the machine learn the pattern, then it may help us to tell who is lying. So the keyword is line, EEG, fMRI, microchip. We may not use all this data, but at least EEG or eye tracking or micro expression data will be used in this project. Okay, that's my present. Thanks for your listening.
Okay, Xinxiang, thank you so much. Just to clarify, so the data you are talking about, you don't have it yet, or?
Yeah, I'm still looking for the suitable data for my project.
Okay, all right. Well, work with the TA and we see where you can get, where we can get you.
Okay. Okay, thank you.
Yeah, the TA will help you. Okay.
Thanks a lot.
The last one, we're doing very good on time. The last one is Yen-Chen. Is that right? Yen-Chen. Oh, Yen-Chen. Sorry, then. How about the should tell her to come up? You should be here. So how about Yuxuan? Did we get her? Okay. So is that all we have from the then we'll wait for the rest. Give me a few seconds here. Yeah. Okay, we'll just hold off on the presentation because we are there. So I think we can stop the recording for now. We can still stay on the screen, but we can stop the recording for now. Ruoqi, if you can.
Yeah. Okay, I just stopped the recording.
Okay, great. So that's the recording will be of today's project pictures will be there, and we will edit it a little bit later. Like we'll cut it into nice meaningful chunks, so that and then upload it on YouTube, and then no, you can speak there and share there. I think that's easiest. Yeah. Are you sharing? Yeah. Okay. We see you now.
Okay.
Okay.
Hi, we're students from the Graduate Institute of Linguistics, and I am Tsu-Yueh. I'm currently
in Dr. Charlene Lee's lab, and I'm actually not previously too knowledgeable in EEG, so I'd say I'm an EEG newbie. And here's my teammate.
And hi, Yen-Chen, and I'm coming from a background of phonetics, and so I have zero experience with EEG, but we're really interested in EEG, and we think that is a really good opportunities for us to get some hands-on experience of the EEG pre-processing first, before getting into the EEG knowledge next semester.
Yeah, and so we're going to be practicing pre-processing with raw data on the open neural side, because we think in this era of open science, it's better that we know how to deal with open data. So we found a EEG data from an auditory output task, and we will be using Python MNE to pre-process this data. So that's about it.
Does your data look good? I mean, like the first data you found.
Oh yeah,
like
actually we've been through some struggles looking for a suitable data set. We found a data that it looked pretty weird with blanks, which made me kind of worried about the participants' brain activity. But hopefully that we could be using this new data set more smoothly.
Okay. So if you want to mute over there.
Okay, thank you. Give me a moment.
Okay, so yeah, thanks. So I think if there are blanks in the data, it would be good if you can fill in the blanks.
Yeah, Daisy is asking a question.
Yeah. Who? Somebody has a question. Oh, is the auditory oddball task for an attention-related study? I believe so. Is that right? Yeah. Maybe the microphone, you can't hear it. Okay. Yeah. So again, you can pick this up in the Discord. I'm sure many people want to help you with the, or who have expertise on that as well. Yeah, yeah. Okay. So that's it, right, today? Okay. So then in that case, we will stop the recording again, and then we thank everyone for